here on page 2 of the notes for 6.5, just talking through these rules. The quotient rule, when you're dividing the same base by the same base, you subtract the exponents. And then the quotients to powers rule, when you're dividing any two things and it's raised to an exponent, the exponent applies to both the entire numerator and the entire denominator. You'll find these on page 376 and 378 of your textbook. I'm going to go ahead and adjust the camera and go ahead to the bottom of this note page so that we don't have to do too many separate videos here. And let's look at the bottom of page 2 for 6.5. And the instructions say to use the zero exponent rule to simplify each expression. So here's what I'm going to show you. I'm just trying to establish a pattern here. So watch and follow along here. If I have 10 cubed, by definition, that would be 10 times 10 times 10. Then if you were to multiply that out to get a number, that would be 1,000. 10 times 10 times 10 is 1,000. Now, if I jump down one and I say now 10 to the second, what is that by definition? Well, that's 10 times 10. That equals the number 100. Let's jump down again, and what if I had 10 to the first? Well, that's just 1 of itself. That's just 10. Of course, that number just equals 10 as well. Now let's look at the pattern that's happening here. Every time when we go down a level here, we're taking away one of the 10s. We're not multiplying by an additional 10, which is a roundabout way of saying that we're dividing by 10 each time. Instead of 10 to the third power, we now have 10 to the second, which means one less multiplication. We're dividing by 10 each time. Okay. Another way to say that would be we are subtracting 1 from the exponent as we move down this list. Okay. And then what would that mean? Well, if we were subtracting, and then if we did it again here, one more step, and we were to divide by 10, or take away 1 from the exponent, we would be at 10 to the 0. Okay, again, following this pattern of 3, 2, 1, 0, subtract 10 each time, or divide by 10 each time. Now we're looking at, well, what does 10 to the 0 mean? We hinted at this on the previous page when we had y squared over y squared. That became y to the 2 minus 2 according to the rule. And we determined that that should be 1. Why? Because the y squareds cancel each other out. Let's look at this. Let's continue this pattern and see what happens here. Again, on the right side, we go from 1,000 to 100 to 10. That's what 10 cubed, 10 squared, and 10 to the first equal. So again, we're dividing each one of these by 10. Well, when we take this last step and again divide by 10, just highlighting it here, if we take 10 divided by 10, our answer should be 1. And so when we're looking at how do you write out exponentially by definition what 10 cubed, what 10 squared, what 10 to the first is, then 10 to the 0 would have to follow. That would equal 1. Okay. And you could actually follow this pattern through for any number. You could take 4 cubed, 4 squared, 4 to the first, 4 to the 0. And we'll look at that a little bit later as well. We'll come back to this concept. But for now, oh, there's one more thing I wanted to say here. When you're dividing by 10, what you're really doing is you're moving the decimal one place or unit to the left. That's what dividing by 10 is. So imagine the decimal's right here. You'd move it to the left one. That would put you at 1.0, or just plain 1. So the rule that we're seeing here based on this pattern is that anything raised to the power of 0 equals 1. Anything, whether it be a letter a number, a decimal, anything raised to 0 equals 1. So what that means is if you had b to the 0, that would equal 1. Okay? If you had negative b raised to the 0, notice the whole thing is in parentheses, so this whole item is raised to 0, that equals 1. But just as a side note, let's keep track of these negatives here. If you have negative b to the 0, notice the difference. In the pink here, there's parentheses. Down here, there's not. That means you have negative 1 times b to the 0. The negative is its own thing separate. The 0 only applies to b, so you have negative 1 times b to the 0 is just plain 1. Negative 1 times 1, the answer is negative 1. So be very careful with those parentheses. Make sure you notice where that negative falls. Inside the parentheses, the exponent applies to it, even 0. Outside, or no parentheses, then the negative is a negative 1, not affected by the exponent. Let's look at these 3 examples and look at that a little bit more closely, make sure it hits home here. When you raise something to the 0 power, 4 to the 0, just plain old 1. Negative 4 to the 0, that negative is inside the parentheses, so anything raised to the power of 0 just equals 1. But right here, negative 4 to the 0, you get negative 1 times 4 to the 0. The 0 only applies to the 4. There's no parentheses here. That negative 1 is its own thing. And that 4 to the 0 becomes just plain 1. So you have negative 1 times 1, and that answer is a negative 1. Matter number, letter, watch for those negatives. It doesn't matter what you're dealing with. What matters is where those parentheses fall. If there's no parentheses, it's considered a negative 1. Or if it's outside the parentheses, it's considered a negative 1. Then the exponent only applies to what's inside the parentheses or the actual number or letter. So give yourself a moment now to tell somebody or talk it out loud to yourself what you just saw here. Again, you can just memorize the rule, anything raised to the power of 0 equals 1, or you can understand a little bit where it came from and help reconvince yourself if you blank a little bit on a test. We've now had one real exam, the primary exam number 1 last week. This is a chance for you to start seeing what does your brain do in a test situation. Does it tend to make little mistakes? Does it tend to copy things wrong? Does it tend to blank out a little bit and forget things that you would know normally? As you notice these patterns, then you start to work towards hedging against that. You try to build up your stamina, your timing, your memorization, whatever it takes. If you aren't sure what you need to do, you notice what's happening, but you aren't sure what you need to do, that's a great conversation to have with me in class. It's a great time to start that conversation. If we need to, we'll finish it one-on-one outside of class. But that's why we have these video lessons. You watch these on your own time, and we come together and use class time to really help you individually with what you're struggling with. Okay, so you've taken a moment to copy these, talk it through, and note any questions you need to bring to class, and then I want you to try number 22 on the bottom here. And pause the video so that you can work this out on your own, then come back and see what the answer is in just a moment. So for number 22, you have a negative 6 to the 0, no parentheses. That's going to turn out to be a negative 1. Plus, you have a negative 6 inside parentheses raised to the 0. That's going to turn out to be a positive 1 because anything raised to the 0 just becomes 1. And negative 1 plus 1 equals 0.